Yeah, so welcome back, guys. This is Madhav PVL, and today we are going to see about speech processing CO3 and CO4. So I think you guys were watching this by subscribing to my channel, but if not, please subscribe to my channel and also share with your friends so that we can just make some other videos with this motivation. So let's get started. So now I just made this notes. So I will just discuss the subject with the help of this notes. So basically list the two phases of supervised learning. So supervised learning has two phases, that is testing phase, the training phase and testing phase. So what is training phase? So training phase is nothing but, so this will be a model and this will be your training set. I mean, this will be the input and this will be the expected output. So we will be giving both to this testing data. So the input will be given and the output will also be given, and with the help of this both, this testing data should predict a model. So after predicting a model like this, so we will be having a testing data. So this testing data will be again given to this particular model, and this model will just print some test results, and we need to just check whether this and this results, the testing results, are getting matched. If this both are getting matched, then that will be a good model. So these are the two phases in a supervised learning: pattern recognition. So training phase, a labeled data set is used to train the pattern recognition. Testing phase, it is a separate data set where the input is sent to the model and the output of the model is checked with the output of the tested data. So this is a tested input and this will be the tested output. So these are the two phases. So what is a non-linear time wrapping? So it is a technique which is used to compare two time series that may have difference in their timings. So basically linear time wrapping is nothing but they both belong to same data set, like they both belong to same plane, but this will have some differences in between them. So it works in finding the optimal alignment between the two line series. So it will just try to align two lines optimally with the help of this non-linear time wrapping. So it is useful when two line series are compared, have different lengths, different sample rates. So it is mainly used to compare things with respect to their variations in the timing and speed. So this is about non-linear time wrapping. So why is time wrapping necessary in recognition of isolated words? So when a person speaks, sometimes there may be differences in timings between words. So basically time wrapping is necessary because we can just say like time wrapping is a concept where it will just provide a sample template. So it will have some testing data where if a person speaks some words, then it will just check with the reference template and it will just come to a clarity. So these variations can depend upon the stress rate and accent. So the person may speak different at different situations. So time wrapping allows the system to compare the sound with the reference template. It allows the system to accurately recognize the words and despite its variations. So basically this time wrapping is nothing but it will be just trained with a huge set of data, so that if a person in any mood can speak like anything, so he may just speak whatever it is, but the machine will be able to recognize it even at a high variation. So this is the concept of time wrapping. And what is the principle of optimality used in dynamic programming? So principle of optimality is nothing but it is just trying to produce a optimal solution. So the principle states that the optimal solution of a problem is done with the help of breaking up the problem into some sub pieces and recursively finding optimal solutions for them. So here we can just say like if we just try to break the solution of A into different pieces, and here we can just say like the pieces may be similar sometimes. So some sub problems may match together. So if they both match together, then with the help of this principle of optimality, there is no need of working on that particular small problem again and again. So once it is done, it can be used for the other problem also. So that is a principle of optimality. Key insight is that if a sub problem occurs again and again, we can use same optimal solution which avoids redundant calculations. So it is used in the formulation of Bellamy equation, which expresses the value of a problem as max or min values of sub problem. So now write the key equation for finding the optimal wrapping path in DTW. So the key equation will be this. So this will be the direction and also the minimum of DTW in between these variables. So this algorithm calculates the cumulative distance to find the optimal path. So after finding the minimum path starting from the points, the optimal wrapping path minimizes the total distance while allowing it to a non-linear time wrapping. So non-linear time wrapping is nothing but if we just try to find a way in a straight line, whereas non-linear time wrapping will just try to find the optimal solution in different shapes. So this algorithm calculates the cumulative distance. Cumulative distance is nothing but the whole distance, and to find the optimal path it uses dynamic programming to calculate them. So after finding the minimum path starting from both points, then the optimal wrapping path minimizes the total distance with the help of this non-linear time wrapping. So this will be a bit confusing, but the only one thing is it will just calculate the distance for finding the optimal path, and it will just do this DTW process for this variables, and it will just try to find the shortest path, and the minimum of these three paths will be considered as the shortest path, and the process of this is done with the help of this non-linear time wrapping. So define local distance and global distance. So local distance are nothing but the distance in between two local points, whereas global distance is nothing but the summation of this distances of local points. So local distances are the distance between individual data points. Global distance is the overall distance between two time series. So it represents the cumulative distance between the corresponding data points. So the global distance is obtained by summing up the local distance. It represents the overall similarity or dissimilarity of the particular model. So the local distance provides the info needed to calculate the global distance. So what is a backtracking? Use it to find the optimal path in DTW. So to use it to find the optimal path in a cost matrix, which represents the alignment between two sequence models of so we can just draw this with the help example. So if we just consider a matrix like this, if this is a starting point and this is the ending point, so it will start from bottom right corner of the matrix and select the minimum of three adjacent cells moving towards it. So it will just select this 3. So the resulting part represents the alignment between the two sequences. So first it will try this. If it is not working, it will go back. Again it will try this. It not working, it will go back. Again it will try this. If it is not working, it is go back. Oh, sorry, this is working. So after this it will try to check out the 3 other points. So again it will try this, it will go back, again it will try this, it will go back, and it will find out the solution. So the resulting path represents the alignment between the two sequences. So backtracking is used to find the optimal path in DTW in this way. So how is a sequential pattern recognition different from other pattern recognition? So sequential pattern recognition is nothing but finding out a problem in a straight way. So sequential programming is different from other types of pattern recognition because it involves the analysis of patterns in sequential manner. Other types of patterns take the recognition of images, voices, etc., which are non-sequential. A sequential recognize takes order and timing deviations to handle the complexities, whereas other types of recognition may have some complexities, and also some noises may also get added because of not following a proper path. So yeah, so why is signal processing useful in pattern recognition? So signal processing is useful in pattern recognition because sometimes the patterns in our daily life may be of signals, speech signals, and some sensor signals and all those stuff. So these signals contain some patterns. So signal processing is useful in the pattern recognition. So with the help of the signal processing is a powerful tool which is used for the pattern recognition. It allows us to extract a meaningful information from that particular pattern. So signal processing is useful in pattern recognition in this way. So what is the need for statistical models of a speech sound? So statistical models of a speech sound is nothing but when a person speaks something, so the machine will try to just draw some graphs like this. So some frequencies will be drawn, and with the help of the statistical models it will be able to find out the peaks of in that particular graph. Like the highest peak will have some alphabet and the lowest peak will have some alphabet. Like for A is having more vibration, so it will just have some frequency, and O will have some low frequency, it will have some other thing. So it is necessary because the features of a sound such as amplitude and frequency can vary depend upon several factors. So with the help of statistical modeling we can find out the mean and variance of these features. This allows us to understand the process of language easily. So with the help of this graph we can easily guess the alphabets. So what is the characteristic of a stochastic model? So characteristic of a stochastic model is it incorporates the randomness or uncertainty in a model. By using probability density function, these models can compute the probability of a new data. So these models are completely used when there is an inherent variability or uncertainty. So if the data is not completed, so the stochastic model, if the data is present in the stochastic model, with the help of with the help of these models, the randomness or uncertainty in a model will be cleared. So that is a characteristic of a stochastic model. So what are the parameters of a normal distribution? Write an expression for the mean of set of 13-dimensional data points. So actually the mean is nothing but mu of I is equal to summation of x minus of I of n. So its a distribution is described into two parameters, mean and standard deviation. So the mean is nothing but the average value of the data points, which can be calculated like this. The standard deviation of the square root of the variance. So xi is the I component of the nth data. So what are the parameters of normal distribution? So parameters are, as I said before, the mean and the standard deviation. Mean is this formula, and standard deviation is the square root of the variance. So these are the two parameters in a normal distribution. So these are the expressions. So what is an expression for the likelihood of a scalar data? X being generated by a Gaussian distribution, y GMMs are more appropriate. So this will be expression. We need to just remember this for the examination purpose. So Gaussian mixture models are more appropriate than a single Gaussian distribution model because the attributes of phenomena are assigned and have multiple peaks. A set of Gaussian in a mixture model can multiple peaks and provide a better fit. So I don't know regarding this exactly, but we need to just remember this expression. So explain Gaussian mixture model, how EM algorithm use it to train a GMM. So GMM is a probabilistic model used for clustering. So if it represents a data set as a mixture of several Gaussian distributions where each Gaussian represents a cluster in data. So with the help of this EM algorithm, the E step and M step, E step is used for calculating the probability of each data, where M step is it updates the parameters based upon the probability calculation. So GMM Gaussian mixture model of it is used to train a GMM EM model. So EM model will just fill up the spaces. If the data is incomplete, it will just try to fill up the places in this Gaussian mixture model. So list the parameters of HMM, state the three assumptions of HMM. So HMM has three probabilities: state transition probability, emission probability, initial state. State transition probability is nothing but it's the way in which it moves from one state to another. So probability, the guessing of the next state, is a state transition model. Whereas emission probability is nothing but it will just determine the likelihood of observing an output. So what output it may just generate, it will just to try to guess a probability. So initial state probability determines the likelihood of starting in a state. So it will just check whether the starting stage of the particular model is perfect or not. So the three assumptions are Markov assumption, output assumption, stationary assumption. So Markov assumption is the future state of the system depends only on current state, not on the past state. Whereas output assumption is the output also depends only on the current state, not on the past state. So stationary assumption is probability remains constant all over the time. The emission probability remains constant all over the time. So these are the three assumptions for this HMM state. So first one is Markov assumption. Markov assumption is nothing but the future state will not depend upon the current or the past state. Output assumption is the output state of system depends only on current state, not on the past state. Whereas stationary assumption is the transition probability and the emission probability remains constant all over the time. Yeah. So now explain the three problems in HMM in detail. So HMM is having basically three problems, that is matching problem, optimal path problem, and training problem. So matching problem is nothing but this involves finding the probability that a given observation has generated. This can be solved by using forward algorithm. Whereas optimal path problem is nothing but it will just try to find the sequence of hidden states which produces an observational sequence. So it will just try to find out the optimal path. And training problem is this involves estimating the parameters of an HMM model. This can be solved by Bound-Well algorithm. So in simple terms, these three problems are about calculating the likelihood of an observation in a sequence in HMM. So these are the three problems, and then describe a GMM HMM model in detail. So GMM HMM model is a type of hidden Markov model which is in each state has multiple Gaussian distribution. So these are having two important parameters, that is transition probability matrix, emission probability matrix. So transition probability matrix is nothing but the way in which a 3 into 3 matrix represents a position and changing from one state to another, whereas emission probability is nothing but it is a probability of observation which is being generated from each state. So to learn the parameters of a model from a data, the bound-bench algorithm is used. This algorithm adjusts the parameters to maximize the likelihood. So what are the support vectors in SVM? What is a kernel? What are the names of popular kernels used in SVM? So in a support vectors are the data points. So in SVM we will be having a structure like this. So here we will having some dots like this and like this. So this is called as a support vector, and these are the division of that particular data set. So support vectors are the data points that are closest to the hyperplane. So this will be closing to the hyperplane. So these vectors play crucial role in determining the two datas in a sum in SVM. So a kernel is a function that inputs data into a higher level space. So it is used to compute the dot product, that is transformed feature vector. So one popular kernel in SVM is Gaussian kernel. So this kernel is used in binary classification tasks and considered most successful, as we need to draw only a one single line. With the help of that one single line we need to determine the data classification in that particular SVM. We use this Gaussian vector. And explain feed forward vector, how FNN can be used for speech classification. So this type of artificial neural network, where if we need to just process the data in a forward direction, so in an FNN the input layer is connected to two or more hidden layers. The output layer generates the output FNN, which can be used in a speech processing for processing speech signals and extracting the relevant information. So to train a FNN we need to have a large labeled data. So the network is trying to know the relation between the input features and the corresponding class labels. So this is done by adjusting weights. So explain convolution neural network, how CNN can be used for vowel classification. So this CNN can be used for vowel classification, like if you just speak some words, then they will be in the form of this, they can be converted into the form of a 2D graphs. So with the help of those 2D graphs we can just check, like when the frequencies are high, then they can be determined as vowels, some vowels and which are not. So for vowel classification, audio signals are converted into spectrograms, which represents the frequency content in 2D image. X-axis represents the time and y-axis represents the frequency. So depends upon the frequencies the vowels can be classified. In spectrograms are put into input layer. After several layers of convolutions, the output is flattened into a fully connected layer. So once the network is trained, we can check for vowels in different speeches. So what do you mean by end-to-end speech translation? So end-to-end speech translation is nothing but with the help of an application or with the help of an algorithm, we can just convert the speech of one language into another language. This type of technology can be found in business meetings, tourism, education, and all those stuff, in all those places. So explain how language modeling is done in automatic speech recognition system. So automatic speech recognition system is nothing but it is just converting the speech into text. So it will just convert the speech into text. During the recognition process, it estimates the likelihood of sequence of words. So here we can just say, like if the sentence starts with I want to buy, then the machine will predict a car. So this will be a common phrase in any dialogues. So we can just say like this. In this way it will just try to predict the thing. So automatic speech recognition system is nothing but if you just pause at one particular thing, it will just try to complete that particular sentence at any cost. So in this way it will just divide the whole sentence into different segments, and after dividing them into segments it will just try to combine two segments each. So after combining two segments each, it will try to perform it will just try to create a phrase with the help of those two things. So compare speaker recognition with speaker identification. Explain with example. So speaker recognition is nothing but it is a process used for the security purpose, whereas speaker identification is nothing but it is just recognizing a person from a group. So this is to verify a speaker with the help of a known phrase, and this is verifying a speaker with in a group of people, like verifying a voice with the other voices, so with the other frequencies. So use cases of voice control devices like Alexa, and this is used in a criminal investigation. So list the different applications of automatic speaker recognition. So automatic speaker recognition has different applications. So 5 of them are security and access control, security locks such as voice control locks and all those stuff. Forensics is forensic investigation and low purpose. Customer care is to analyze the sentiment of that particular customer. Healthcare is to identify the patients based on their voice. Personal assistant is to use the Alexa and as our personal assistant. So explain the speaker verification system in detail. So speaker verification system is nothing but it will just take the input, and during the process of pre-processing it will just try to remove the noises. After removing the noises, it will extract the features from that particular voice, and after that it will just create a speaker model with the help of those extracted features, and then speaker enrollment will be done. Like this person is speaking, it will just come to clarity. So captures the speech signal from microphone, it is pre-processed to remove the noise, it extracts the relevant features, it creates a speaker model, speaker voice is recorded and used to create speaker model, and it is saved with sound and it allows the user. So compare the text dependent and text dependent independent speaker recognition system. So text dependent, text independent. So it is nothing but the paragraph is known for that particular system, and in this the paragraph is not known. It need to recognize the speaker with the way in which he speaks. So it requires the speaker to say a specific phrase, and the speaker can say anything in this. Whereas generally high accuracy because of a known phrase, it is having a lower accuracy because it will just take some time to recognize that particular person. So system is simple because of recognizing known phrase. Here system is complex because of unknown phrase. So these are less tolerant to variability because the phrases are fixed, where the variability is more complex because we don't know what the user speaks every time when he wants to unlock the device. So explain deep neural network based speaker recognition system. So deep neural network based speaker recognition system is nothing but it need to have a high level of labeled data with which we can just train a model, and after training a model we can just analyze and extract some patterns in that particular so deep neural network based type of system which uses technique for recognizing speaker. Firstly, find a larger data set with different speakers, and this data is used to train a deep neural network which is of many layers. So during training it will extract the useful features from the data, and when the model is trained we can just give some new input and we can find out whether the user is there or not. So this one and only major note is that this requires a larger data sets and the quality of the audio devices, I mean the way in which the whole speech is getting recorded, those the devices which were used for that testing purpose should be of a high quality for a better result. So what is language identification? What are different approaches used for language? So language identification is done in 3 ways. So it can be done in 3 ways: statistical method, rule based method, ML based method. Statistical method is nothing but depend upon the frequencies on that particular graph, we can just check out which language is that, and rule based are nothing but based upon the linguistic rules we can just find out the language, and the ML based model is nothing but it will just work on some different data sets and it will just recognize the patterns and find out the language in which it is performing. And this may have many applications. Machine translation. So by identifying the text, a machine can translate the text in desired language. So content filtering is it is used to filter out the content that is inappropriate. Information retrieval is by identifying the present document, it will just find out the content in that and it will just try to deliver something relevant information. So explain I vector model of a speaker recognition. I vector model is nothing but it will just divide a particular speech into different segments or frames. This is because speech signals vary over time. Next, features are extracted from those segments with the help of MFCs. So these features are extracted and then used to recognize the patterns. So in this way the I vector model is nothing but it will just represents the speaker voice and all those stuff. It will just try to extract the features from that particular speech signal by cutting them into some pieces, and after extracting that it will just take the help of MFCs, the features are extracted and then use it to recognize the patterns. So after the patterns are recognized, it will get the sufficient data for a speech signal. So what is a text to speech system explained with a block diagram? So first text analysis is done, and then mapper is done, and then speech synthesis is done. Text analysis is nothing but it will just take in the input data, and it will just check for the pronunciation, parts of speech, text normalization and phase breaks, and it will just complete this mapper process. So mapper process is nothing but it generates a phonetic translation of the input text. Phonetic translation is nothing but the way in which the frequencies are done and the way in which the gaps in between text occurs, all those stuff. And then speech synthesis is nothing but it will just generate in the form of some waves and all those stuff. So finally the waveform generator converts the speech synthesis into a proper voice module which can be heard through speaker. So finally, what are the different features which we need to incorporate for the synthesis of a natural speech? So prosody, it refers to the patterns of stress, rhythm and speech. Phonetics is nothing but it refers to the sound of that particular speech. Syntax and grammar is nothing but this can affect the way in which a sentence is spoken. Emotion and expression is nothing but the way in which we present the sentence, the way in which it is produced. So these are the different features which we need to incorporate for a synthesis of a natural speech. So what is a speech enhancement task? What are the different applications of speech enhancement? Speech enhancement is nothing but to make a speech feel good. So making it a better, we can just do that. Like it is a process of increasing the quality and intelligibility of a speech signal that are degraded by noise distortions. The goal is to remove the unwanted noise. So applications are communication systems. So in this, the speech signals may degraded because of noisy channels. So hearing aids, people with the hearing aids may feel difficult to hear noise, hear the information in a noisy place. So voice control system is if Alexa needs to listen our instructions, so there shouldn't be any noise. So for this applications we can just enhance our speech. So with the help of enhancing our speech, we can just perform these tasks very easily. So these are some of the important questions for speech processing, CO3 and CO4. Thank you for watching. Please subscribe to Works of the College and also share with your friends. Thank you.